What's up, guys? Today we're going to be reacting to a video called Why Unreal Engine 5.3 is a Big Deal. For those of you who don't know, Unreal Engine is one of the popular game engines out there. So this is kind of a big thing. I've seen a lot of content creators watch and react to this video. So I wanted to jump in as well. So let's go ahead. Let's dive right in. Let's go.
Unreal's newest update, Unreal Engine 5.3, just released, and it is a big deal. The main reason is nanite landscapes. When Unreal Engine 5 came out, it introduced a revolutionary new way to render geometry called nanite. To briefly sum up nanite, every object you see in computer graphics is made up of tiny flat planes of geometry called polygons. The more polygons you have in your environment, the longer it will take to render. This is why video games have made a system called level of detail, or LOD for short. The further away an object is from the camera, the less polygons it will use to render that object.
I see.
This makes games run faster, but we are limited in the amount of geometric detail we can have. Nanite fixes this, because it uses dynamic level detail, which means you can have an object with millions of polygons without any LOD.
So, is this... I hope this reduces pop-ins. Because one of the things that, are really annoying about most modern games with high-end graphics are the pop-ins, right? Because your hard drive or your SSD, even SSDs aren't really fast enough to load all of them. So I hope this does fix pop-ins.
Because the geometry deforms, lowering the amount of polygons on an object. A good example of nanite in use is this city. If I come up to lit, nanite.
Yeah, if you look further at the back, yeah, they're pretty well rendered, and yeah, this is how you would see it in real life, I guess, right?
Triangles, we can see nanite in action. Every color is an individual polygon, and there are millions of them. The biggest issue with nanite is that when it released, it only worked on non-moving static objects. It was only really good for objects like rocks and cliffs. This changed with the Unreal Engine 5.1 update. It introduced nanite foliage, which gave us the ability to create forests with an unlimited amount of detail. Here's a world with over 100,000 trees without any LODs.
I remember watching a video of that. Yeah, but I wasn't making reaction videos back then, and it was really cool. It's holy shit, you can do this kind of thing now. But I think the reality is it still really needs a lot of processing power. We can do that. It's possible, but you still need a pretty beefy computer. But the thing is, in time, our video cards, our CPUs, our GPUs, CPUs, our computers in general are gonna get more powerful, and then yeah, this thing will become easier to how do I say this? Will become easier to use, right? Or deploy.
Landscapes, which is the biggest part of any environment, was still missing nanite. Landscapes allow us to create large open worlds easily. Using the tool, we can sculpt, add height maps, and paint different materials quickly. This means landscapes were stuck using low resolution geometry, and it hurt our game's performance because Unreal has a hard time rendering non-nanite objects. And all the tech demos that...
Really? So, wait, if that's the case, then they should be using all nanite now, right? Okay.
The game's release, to avoid these issues, they didn't use landscapes. Instead, they faked landscapes. This desert ground isn't actually a landscape. Instead, it is a bunch of nanite objects stacked on top of each other to make it look like a landscape.
Okay. Finally, that makes sense, because that's why when you accidentally clip into things, it's hollow inside, right? Sort of. I don't know if I'm right about that, but I think that's how I see it.
In 5.3, nanite officially supports landscapes. To activate nanite, select your landscape, and then within the details panel, enable nanite, and then build data. Now that it's enabled, we can watch the geometry dynamically deform. It is that easy to enable nanite on our landscapes. In the first version of UE5, we made this village on the channel, but at the time, the only objects using nanite were rocks and the buildings. Now in UE 5.3, the entire world is nanite.
Holy shit.
There isn't a single object that isn't using nanite.
This
means we can get an infinite amount of detail from our environments, and the performance is a lot better. Nanite landscapes can now also use tessellation to add more detail.
Tessellation, from my understanding, is the roughness of a surface. For example, if there's zero tessellation, a rocky surface will actually look flat, and when your character walks into it, it's It's like walking through a flat surface. But with Tessellation, you can simulate like rocky areas or like slopey areas or something, like rough roads, pretty much like rough terrain. That's how I understand Tessellation. I hope I'm right.
In UE4, we had tessellation, which allowed us to create displacements
Okay,
from
there we
a
go.
high texture.
There we go.
When
That's what I
Unreal
meant.
Engine 5 released, it was removed. But now it
Oh
is back
wait,
and it is
really? I didn't even notice that they removed Tessellation. Because some of the games that I played that use UE5 did have Tessellation. Wait a minute, that's really? I didn't know that.
using nanites. This means we can change objects from the
But he did say on release, so when 5, I don't know.
material editor. We have a brand new input called displacement where the high texture goes. Tessellation can
Here we go.
convert any simple mesh
Ooh.
into an object with thousands of polygons just with a texture. Here's an
Ooh.
environment with a landscape that isn't using
See, this is what I'm talking about. Like, it looks like very rough, but it's actually flat.
displacement. The world feels kind of flat,
Mhm.
and here's the same landscape
Whoa.
with displacement.
Okay.
The ground has depth to
That's
it,
what I'm talking
and
about.
it looks a lot better. Everything you see on screen,
Way
except
better.
the plants, is the landscape. All the rocks, twigs, and roots are not objects. They are a high texture. And whenever I make a
Nice.
change to my landscape, the nanite displacement remains in effect. For the first time in gaming, we're not limited by how many polygons are on screen. We can have infinite geometry everywhere.
That is so
The
cool.
next major feature is better volumetric fog and smoke.
Ooh.
Unreal's had volumetric fog for a while.
I think they like showcase this in Counter-Strike, the new Counter-Strike, the new CS:GO, right? CS:GO 2, I believe. I think it used the new volumetric smoke. Correct me if I'm wrong on that, but I did watch a few trailers on it and it looked very, very cool.
Which gives us the ability to have realistic light scattering in fog and smoke.
That's so
To
cool.
enable volumetric fog is easy. You just have to click volumetric fog within the height fog to turn it on. Now we get dynamic fog that interacts with the lighting.
Ooh.
So I can move the sunlight around and you'll see those God rays change direction. It is
Holy
the secret
shit.
to make any of your environments stand out.
That's
Here
so
are
cool.
before and afters of an animation with and without volumetric fog. The world
Ooh.
feels more realistic and it looks visually more interesting with fog.
Hell
The
yeah.
only issue in Unreal was that it was problematic to create finely detailed fog. It could only
I
be
see.
used to create large splashes, and it was
To be
hard to
fair,
use
like some of the fog, like in older Unreal Engine versions, they look good because the developers themselves are pretty smart. They know how to use tricks to like make it feel and look real. Like you can tell when like fog is, not really given a lot of attention, when it's very obvious when it's bad, really. But some people do it well, even without this 5.3 thing. But now that we can do this, like holy shit, it's gonna be. I hope most games going forward are gonna look really, really good and not like dog shit. But there's always gonna be dog shit games, no matter what we do. So yeah, I just hope. Sorry, I'm mixing up my words. I just hope most of the games are gonna look really fucking good.
metrics for complex shapes like explosions.
Ooh,
Instead,
okay.
explosions and smoke had to be faked with billboards. Billboards are just a flat surface with an animated texture.
Okay, this has been used a lot. Like, so how's it gonna be now with 5.3? Is it gonna be 3D, fully 3D?
See that this is just one single plane. The smoke isn't actually 3D.
That's
Obviously, this doesn't look the best because when I move the lighting in my environment, the smoke stays exactly
Yeah.
the same. We don't see any changes because after all, this is just a flat 2D texture.
True.
In 5.3, sparse volume textures
Ooh.
fix this. We can now
Okay.
import complicated volumetric simulations from programs like Django.
So this is
FX.
what we saw in CS:GO 2, I believe. The smoke.
Here is a sparse volume explosion imported from Django FX into Unreal.
That's so
And if
cool.
I pause the simulation, you can see it is not being faked by billboards.
Ooh.
This smoke simulation is completely 3D.
Nice.
If I move the light around, it will dynamically change the way the smoke looks.
Let's
The
go.
smoke is able to cast shadows onto itself. We can even use sparse volume textures to represent clouds. And what's amazing about these clouds compared to
okay.
Unreal's default cloud system is that I can move them around and rotate them. So I get full
Ooh.
control over where my clouds are in the sky. And
That's
if
so
we zoom
cool.
out, we can even see that these clouds are massive objects so that I can move around and place them exactly where I want them to be.
Nice.
Volumes can even replace some particle effects. For example, this fire here is very similar to the explosion.
That's
where
true.
If I go into wireframe,
to be fair though, most fires pre 5.3, they do look kind of good. I've never really tried to go around any fire, 'cause, you know, I run past them and oh, there's fire over there. But yeah, they are pretty similar. They're flat surfaces basically. Oh, whoops.
It is just a couple of 2D planes that simulate a fire animation. And then if I look down directly at it, this effect immediately breaks. And now here's that particle effect, but it's replaced with a sparse volume texture.
Whoa.
And this fire is now completely in 3D. It's not a 2D plane that's facing the camera. So if we look at it from the top down,
it looks like the smoke is too much though. I don't know.
This fire is real, and
I mean, this isn't really like...
Another major feature is that we can now create animatable characters directly in Unreal Engine. In Unreal, we have been able to create rigs and animate characters. This animation you're looking at right now was animated entirely in Unreal. It wasn't created in another program like Blender or Maya. The biggest part missing in the character creation workflow was skeletal mesh editing, which is the process of creating bones in a character. UE 5.3 adds a skeletal mesh.
So you can do that now. That's so cool.
This means we can create bones and weight paint directly in the editor. It is now possible in Unreal through modeling, weight painting bones, rigging, and animating using Sequencer to create an entire character just using Unreal. We also get a new cloth editor to create realistic simulations for clothes. Users can define exactly how a cloth simulation can interact with a character. And then artificial intelligence will bake that interaction into an animation.
Let's go. So this is what I've been talking about before, guys. This is one of the like really cool and actually useful uses of AI. Like when people like think of AI, usually like average people, they usually think of the AI art or ChatGPT, right? Those are not what AI is for. Like those are more like training grounds for AI. The real use of AI are things like these, like to help us fill the gaps basically, right? Like to make things easier for us to do.
Also got a major update.
I'm so excited for that.
If you don't know, Unreal Engine 5 introduced a brand new lighting system called Lumen. Lumen gives us dynamic bounce lighting.
We saw that in the PS5 tech demo years ago, I think, right?
Real time. It is important to know that bounce lighting is also called global illumination.
Global illumination is basically, well, as the name states, it's how the light interacts with the whole world, basically.
Illumination is a process of light rays bouncing around, illuminating your entire world.
Exactly.
Before Lumen, game developers faked global illumination through a process called light baking. Light baking is rendering bounce lighting before the game is played.
Okay. That's why it's called light baking.
Then stored in a texture called a light map, which is then overlaid on top of the world to make it look like the light is bouncing around in real time.
I see.
When in reality, it's just a pre-rendered texture. But now the
so
problem
if you move the
is that
chair,
illumination
the shadow's gonna
isn't real
stay.
time. As soon as I make a change to the light map, it is no longer in sync.
Got it.
We have to rebake the entire environment all over again, which is time consuming.
Makes sense.
This is why Lumen is a big deal, because it is true real-time global illumination. We don't have to bake our lights, but the downside is that Lumen is very expensive to run. Not every computer can run it because it is computationally
See, this is what I was talking about. Like, all of these are cool, but probably at the moment it's very like, you know, power hungry, processor hungry. It's very demanding. But in time, the thing is, it's just now. In time, this will all become easier to render eventually, right?
Expensive. This is why Unreal games like Valorant still use baked
I didn't know Valorant was made with Unreal. That's
It is a competitive game, so every frame matters.
I guess it makes sense for competitive games because, you know, you don't really need like super high graphics for competitive. You need like response time and high frame rate.
Open up a Valorant map in Unreal, you will see it using baked lighting. If I move an object, the light doesn't update until I rebake the environment. Even though Lumen exists, a lot of games still have to use baked lighting because it is just more performance.
That's true.
You can get 120 frames with baked lighting. It's hard to get that many frames with Lumen. Hardware hasn't caught up yet.
Makes sense.
This environment is using baked lighting. And one of the biggest
eventually our hardware will catch up. Like the really high-end machines probably can do it, but you know, like the mid-tier and the starter tiers probably can't.
Issues with baked lighting is that it doesn't have any reflections. You'll see that this entire environment is broken because the reflections aren't working. And we can fix this by manually adding in reflections by using a reflection capture within Visual Effects, Sphere Reflection Capture. This will capture a 360-degree texture of my environment and then project it onto any reflective surface.
Okay, that's how they do
it. The workflow to get reflections everywhere is that now I have to create another.
It's very taxing, yeah.
And move it to where there's a bunch of reflections.
It's very taxing.
Then I have to create
that makes sense.
Another one.
Ooh.
And then continue the process throughout the entire environment.
Holy shit.
And if we have a large environment, this process can be very tedious. Here's an environment that's using Lumen, and reflections work immediately.
Ooh.
We do not need reflection captures. But the issue is that we had to use Lumen Global Illumination, which hurts our performance.
Oh, okay.
In 5.3, we now have the ability to use Lumen reflections with big lighting. So we do not have to use Lumen Global Illumination to get Lumen reflections. To get this feature, go to the post-process volume and set Global Illumination to none. So we're using the baked lighting and not Lumen. And then set reflections to Lumen. Now we're using baked lighting for global illumination and only using Lumen for reflections. We get the high performance of static lighting with the accuracy of Lumen reflections. Plus, we no longer have to set up reflection captures. Also, Lumen reflection now supports multiple bounces. So let's say we have a mirror right here, and then across the hallway we have another mirror. Notice how we can't see the other mirrors in its reflection. That's because we don't have enough reflection bounces. So if we go back into the post-process volume under reflections, we have a brand new setting called max reflection bounces. If I set this to 2, now we can see the reflections. The modeling mode user interface got a facelift, and now it is a lot easier to use. All the tools are neatly organized into categories, and let's say there's a tool I use a lot, like display. Then I can right-click and add to favorites, and now I can quickly access that tool within the favorites tab. Masked materials like foliage are now 20% faster, and there are more shadow options for Nanite to help optimize shadows. Unreal's shadow system, called virtual shadow maps, are right now the main bottleneck to foliage. So this gives us more control over what types of shadows should trees cast. And finally, a big update for Mac users, Nanite is now supported on all Apple M2 devices. Finally, Apple users have access to both Lumen and Nanite. When UE5 first released, it didn't have either feature. This also means that Unreal Engine 5 with Lumen and Nanite will be able to run on the Apple Vision Pro. The programs you're developing now on Unreal could be used for the Apple Vision Pro in the future. The possibilities are endless for Unreal. These were all the major changes to UE 5.2, but these are just the ones I think are important. Of course, there's a bunch of other changes you can check out by going to the Unreal release notes. Unreal is more important than ever because half of all next-gen games are being made in UE5.
That's true.
There's no better time to learn Unreal Engine than now. Luckily for you, I have an entire free course right here on YouTube, which goes over the essentials.
I might learn that. I might try to study that.
You can learn how to create this world you see right now. You can check it out. Link in the description below.
All right, that was a very nice video. Now, in connection to my previous video, like about, you know, do graphics still matter? They fucking do. They fucking do, guys. And, you know, with most developers using UE5, I just hope they don't, like, you know, like I said in that video about this graphics matter, I just hope they don't try to make things very similar. I hope they try to find their own art style while using the same engine, right? Because pretty much eventually the art style will determine, you know, is a big determining factor of how good a game is. So yeah, that's it for now, guys. I will link the video in the description. Make sure to give Unreal Sensei a like, a sub, share this video if you like it. So yeah, I will see you guys in the next video. Bye bye. Otskuro.